ratios, I think the easiest way is to start with equation 1, and I'm going to solve for a. Okay, and I'll show you what that looks like. So if I want a on its own, I need to divide across that r squared. And I can do that quite easily, just like this. Now, if I've done that, I now know what a is. Now, there's no point plugging it back into itself, okay? Because in fact, that doesn't actually work. This is where we need two equations, because now I'm going to chuck that a into my second equation, okay? So now I'm going to write this equation out again, but where there was an a, I'm going to pop this as my a value. So I'm going to get 12 over r squared times r to the power of 5, okay? Now, what you'll notice, and the point of doing this, is that I've gotten rid of the a's altogether, and now I'm just solving for r. So if I can find what r is, that's the ratio. And if I could find what r is, then I could come back to this part here, where I've got a equals based on whatever r is. I could pop in my value for r, and then I can get my a as well. So that's why we're setting it up like this. Now here, when I multiply, and I can get rid of these brackets if they're confusing you, when I multiply that r to the power of 5, he's going to end up going on top. So it's going to be like 12 r to the 5 over r squared. Now that 12 is going to stay there because there's no number on the bottom to cancel it out. But what will cancel is my r's. So what we're looking for is, where is the bigger power of r? It's clearly on top. And the lesser power is how many are going to cancel away from the power. So I'm going to get rid of 2 from the bottom, and that's going to leave me with a power of 3 on top. So by simplifying that fraction, I'm going to get 96 equals 12r cubed. Now again, I just want the r bits on its own. I'm going to deal with the cubed in a minute. I'm going to get rid of, go away Porter, I'm going to get rid of the 12 first. It's timesing there, so all I can do is just divide by 12 on the other side. Okay, 96 over 12 is going to be 8. And now I'm doing a cube root, because that's the way we get rid of a cube. The same way to get rid of a square, we have to do square root. But the thing with a square root is we have to consider it being positive or negative, because it could have been either. Oh goodness. When we do a cube root, there's only going to be one answer, because if it is positive, then the root must have been positive, the number that we cubed initially. And if it's negative, then that root must be negative. So when I do my cube root of 8, you can chuck that straight in your calculator. You're going to get an answer of 2. Again, when I do these with a lesson, this is way more steps than you really need. If that's what you find comfortable, go for it. You can absolutely, honestly skip from here to here. That's fine. Okay, as long as you get the right answer, obviously. Now that we know what our r value is, we're going to pop that back in to find our a value. Okay, so we know that the ratio is 2. Now I'm going to pop that in to figure out what my a value is. So here, a is going to be, well, what's 12 over 2 squared? 12 over 4 is 3. Now I've got a and I've got r. Now what I could do is I could write the explicit formula. They haven't actually asked me to do that. They've asked me to write the recurrence relation. Now remember, a recurrence is like recurring. It's like following on from the thing before it. So my recurrence relation is going to be writing a term based on the term before it. Remember, in geometric series or sequences, we get the next term by multiplying by r. So it's usually going to be r times the term before it, where the first term is a. I know what r is because it is 2, and I know that a is 3. And that's just a general formula for any term, writing it based on the term before it. double check the question to make sure we haven't missed anything. It hasn't said find the fifth term or anything like that. It doesn't, we're good, and we're done with that one. Okay, the only thing that's going to be a little bit yucky about this one is that we're dealing with some roots. Otherwise, it's the same idea. So, considering this sequence here that has a finite number of terms, it finishes. It's not infinite. Okay, we're going to find the common ratio. Now, the common ratio I'm going to do by grabbing the second term and dividing it by the first term. Now, you are welcome to do that on your calculator, but the reason I wouldn't do that on your calculator is you'll notice that 4 and 4 are going to cancel, and we're going to be left with root 2. Now, if this question said anywhere exact answer or exact values, exact means giving root 2, not its surd approximation, 1.1 blah, 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 blah. Okay, because if you type root 2 into your calculator at any point, you're going to get a decimal because your calculator doesn't like to leave it in surd form. Some do, computers will most of the time, but if you type it into your calculator, you will get a decimal. So if it said exact anywhere, you would do it as a surd, and you'd have to do some algebra to keep it as a surd. We're going to treat it that way, but technically this question doesn't say exact anywhere, so you could get away with it. So we found the common ratio, which was root 2. Now it wants us to find the sixth term, and to do that we're going to need to write the formula. And to write the formula, we can go to our reference sheet. It's going to be a times r to the n minus 1. I've got my r, but I still need to find my a. But again, a is just the first term, so a is just going to be 4. So popping back into this formula, it's just going to be 4 times the ratio. Now, just to be really clear, I'm going to do the ratio in brackets. Doesn't hurt, even if it was just a 3 or a 5, chucking that bit in brackets just kind of saves you a bit of drama. And now, that would be n minus 1. So when I do this for the sixth term, it's going to be the same characters, but 1 less than 6, I'm going to have a power of 5. Now that's a number, okay? If you were to type this into your calculator, you can get an answer. It would be 22.63 rounded. But again, if this said exact, then we can't do it in our calculator. Now what you would need to consider is, well, what is this root 2 to the power of 5? That means root 2 times itself 5 times. Okay, now hopefully what you remember is that root 2 times root 2 is just 2. And I've got another pair of root 2 times root 2, which is just 2. And I've got one lonely root 2. Now what that means is I'm going to have, well, that's going to be 4 times root 2. And that's one way that you can figure these out in your head, just by like breaking it up. There are other shortcuts there. If you know your stuff, you can jump to it being an odd power and you can figure that out. But if you're not that confident, you can break it up as well. So it's going to be 4 times 4 root 2, or 16 root 2 if you wanted to give an exact answer. Okay, now it wants to solve for n. Now we haven't done this yet. N is going to be the number of terms in the sequence. Okay, so remember that I said it was finite. It ends at 256. So what I'm being asked to find is, well, what spot is 256? Okay, so let's start by writing it out. We know our formula, which we found a second ago just here, is going to be 4 times root 2 to the n minus 1. Okay, now I know what my final term is. It's 256. What I don't know is what this n value is going to be. I'm bringing up a calculator, by the way. I'm going to cheat in a second. So what we need to do is solve for n. A couple of methods we could use here. The first thing I'm going to do is get rid of that 4 by dividing it across. So I'm just dealing with one thing with its power. So I'm going to go 256 divided by 4, and I'm going to get 64. equals root 2 to the n minus 1. Now what I'm left with here, I have something with a power equals an answer. Now, if you're ever stuck with your unknown, your pronumeral as the power, we can use logs and exponentials and their relationship to rewrite this so that the power is the answer or the subject of the equation. So I'm going to do that because we know that where you have, I'll write it another way, where you have a base with a power and you get the answer, which is what we currently have in that setup, we can rewrite this as log of that base, where the answer is what's usually in brackets, and that's going to give an answer of that power, or kapow. Okay, so I can rewrite this in log form by writing as log of root 2. Okay, my answer is going to be 64. I'm choosing to put that in brackets just because I find it clears things up a little bit with log questions. And then our answer is going to be n minus 1. Now, it might be really tempting to type this into your calculator, and you can. I believe it actually comes out nicely. Let's just quickly check that. So if I was to write log, oh gross, I need to find where to do, you can see that I am fully going blind. We're not going to bother with that because I can't find it on my little calculator. So we're going to leave it as log form. You could type it into your calculator if you wanted to. The only thing I need to do to get n on its own is I need to get rid of this minus 1 by adding it onto the other side. So my final answer is just going to be n is log root 2 of 64 plus 1. Now again, if you can type that into your calculator, you will get an exact answer, and that is the spot. Cool. Just a little bit of rearranging, and that's where logs can come in really handy. Okay, I think we've got 2 more examples to go through, and then I'm going to go through your tasks with you. These are more application, a little bit harder. So we've got Caitlin. She is investing, I might highlight as we go through here, $21,000 in an account that earns 7% per annum interest calculated at the end of each year. Okay, we're going to complete the table where A, which is that bottom row, is the value at the end of each year. So that's going to be like with interest, rounded to the nearest dollar. Okay, so there's a couple things happening here. Remembering that this is a geometric application question, we need to start with our A and our R the same way we have been. So our A value is always going to be what we start with, so 21,000. Now our R is going to be what we're multiplying by. The problem here is that if you were to multiply by 7% each time, you're actually going to be getting a infinitely decreasing amount. It'll be really small because you're finding just 7% of the term before it. That doesn't make much sense. That is not how banks work. Instead, the way banks work is they find out how much money you have currently. In other words, your current amount, your whole amount, and then they're going to add on 7%. Now I'm going to write this as 1 plus 0.07, which is the same thing as 100% and 7% more, but we tend to write these in decimals because it's a little bit easier to work with. So if I got 1 plus 0.07, then the actual amount that I'm multiplying by at the end of each year is going to be the amount that I've got plus the interest rate as a decimal, so 1.07. And that is going to be my ratio. So that's a really common way to scaffold these geometric application questions, where you need to consider it's the amount plus interest, so adding that on. Okay, so let's fill in the table. The first spot you're going to be filling in is just here, and that would be our A, so our 21,000? Yeah, 21,000 multiplied by 1.07.